So we've got negative 1 to the n plus 1 times negative 2 to the n, because 3 minus 5 is negative 2, over n times 2 to the n. And what I'm going to do so that I can simplify this is I'm going to split the negative apart from the 2, and I can do that as long as I give each of them the exponent that belonged here. So I'm going to say that this is negative 1 to the n power times 2 to the n power. So I'm rewriting this right here. So what that means is that my 2 to the n on top and my 2 to the n on bottom can cancel. And now that gives me the series negative 1 to the 2n plus 1, because I'm multiplying the same base so I can add my exponents together, over n. So if this exponent up here, it's 2n plus 1, you guys might recognize that's going to force that exponent to be odd every time. That means that this fraction is always going to have an odd number on the top. So this right here, always having, and it's actually always going to have negative 1 on the top. So this is negative 1 over n, which is a p series, where the p equals 1, it's the harmonic p series, and the harmonic p series diverges. So even though it looks like it would alternate, it does not alternate, because the exponent will always be odd. So it's always going to be negative 1. So that means when we look at our notes, we can go back over here, and this 3 should have a parenthesis. The 3 is not included in the interval. All right, let's go ahead and check the 7. So we have negative 1 to the n plus 1, 7 minus 5 to the n. So when I write this one, then you'll notice that we have positive 2 to the n and positive 2 to the n, and those cancel. And we're left with a series negative 1 to the n plus 1 over n. So if you're looking at this is a harmonic p series again. We do have p equals 1. However, this is an alternating. So we can do the alternating series test on this just to see if, even though it wouldn't converge absolutely, it might converge conditionally if it converges when the alternating sign is there. So if you guys recall, there's 2 conditions we need to check. One is that the limit as n goes to infinity of 1 over n is 0. So we ignore the alternating part, and we just use the coefficient that would be there, which is a 1, and that's true. The limit is 0. And then the second condition is that 1 over n plus 1 is less than or equal to 1 over n. And when we look at that, that's true. So we know that the alternating series would converge. If it was always negative, then it wouldn't converge, it would diverge. But if it alternates, it actually does converge. And so that means that the 7 is included. So if we go back over here, our interval is from 3 to 7, excluding 3 and including 7.